In this video, I like to introduce two things. First one is characteristic equation and the second one is characteristic value or eigenvalues. First one is characteristic equation of a square matrix and characteristic values or eigenvalues of a square matrix. Okay, first I am going to define what is characteristic equation is. Characteristic equation of a matrix. Suppose we have a square matrix A. Then its characteristic equation is determinant of A minus lambda I equal to 0. This equation is called characteristic equation of the matrix A. For example, if I take A equal to, we need a square matrix. If I take a square matrix 1, 2, 0, 3. I take a square matrix A equal to 1, 2, 0, 3. Then we need to find the characteristic equation of the matrix A. That is by the definition. First we need to find the matrix A minus lambda I. Then we need to take its determinant and which is equal to 0. That equation is called characteristic equation. So I try to find the matrix A minus lambda I. We know that I is the identity matrix, so we can write I as 1, 0, 0, 1. Then lambda I will be lambda 0, 0, lambda. This is lambda I. Then A minus lambda I is 1, 2, 0, 3. That is A minus lambda I. Lambda I is lambda 0, 0, lambda. This is A minus lambda I. So we can subtract these two matrices, that is 1 minus lambda, 2 minus 0 is 2, 0 minus 0 is 0, 3 minus lambda. This is called A minus lambda I, This matrix is called characteristic matrix. To get characteristic equation, we need to find determinant of the matrix A minus lambda I equal to 0. That is, we need to find determinant of this matrix. That will be 1 minus lambda into 3 minus lambda equal to, that is the determinant of this matrix. Determinant of this matrix is 1 minus lambda into 3 minus lambda, which is equal to 0. This equation is called characteristic equation. If we simplify this equation, then we will get that what is lambda square minus 4 lambda square minus 4 lambda plus 3 equal to 0. This is the characteristic equation of the matrix A equal to 1, 2, 0, 3. This is called characteristic equation. If I take a 3 by 3 matrix, 1, 2, 3, 0, 1, 4, 0, 1, 2, 0 and 2. We need to find the characteristic equation of this matrix A equal to 1, 2, 3, 0, 1, 4 and 0, 1, 2. Okay, also please note that here A is 1, 2, 0, 3. And A minus lambda I is 1 minus lambda, 2, 0, 3 minus lambda. That is characteristic matrix A minus lambda is nothing but just subtracting minus lambda, just subtracting lambda from its diagonal entries. That is called characteristic matrix. So to find characteristic equation of this matrix, first we need to find A minus lambda I. By the last formula, last method, we can find A minus lambda I by subtracting lambda from diagonal entries. That is, A minus lambda I will be 1 minus lambda, 2 minus lambda. This is characteristic matrix, that is A minus lambda I. So we need to find determinant of A minus lambda I equal to 0. That is, we need to find determinant of this matrix. We can find this determinant of this matrix by using this column. using this column. So the 1 minus lambda into determinant of 1 minus lambda 4 1 2 minus lambda. All other entries are 0, therefore determine this one equal to 0, therefore which is equal to 1 minus lambda into determinant of this 2 by 2 matrix is 1 minus lambda into 2 minus lambda minus 4. And we can simplify this one 1 minus lambda into 1 minus lambda into 2 minus lambda minus 4 into 1 minus lambda. And we can simplify this equation, which is equal to 0. This equation is called characteristic equation. This is the characteristic equation of the given matrix A. And also the first one was 1, first matrix 2 by 2 matrix 1 2 0 3 1 2 0 3. We got this characteristic equation by using the usual method, by the using definition. We got the characteristic equation, that is lambda square minus 4 lambda plus 3 equal to 0. We can find, there is a shortcut method to find characteristic equation of a square matrix. First, I am going to discuss what is the shortcut method of characteristic equation from characteristic equation of 2 by 2 matrix. Here, like this, if we need to find characteristic equation of 2 by 2 matrix, then we need to start from lambda square. Since it is 2 by 2 matrix, we need to start from lambda square. If it is 3 by 3 matrix, then we need to start from lambda cube. Since here it is a 2 by 2 matrix, we can find its characteristic equation by starting lambda square. Then the next term is the sign minus lambda and minus. Then we need to find the trace of this matrix, that is sum of diagonal entries. Here sum of diagonal entries 1 and 3. No, some diagonal entries are 1 and 3, and its sum is 4. Therefore lambda square minus 4. Then next term will be lambda. Next term, here I used negative. Then in the next term I need to use positive. Then then next term is determinant of this matrix. That is 3 equal to 0. This will be the characteristic equation of this matrix. This is aiming to the usual method. This is the shortcut method of 2 by 2 square matrix. Okay, then in the last section we found the characteristic equation of 3 by 3 matrix, that is 1 2 3 1 2 3 1 2 3 1 2 3 0 1 4 0 1 4 0 1 2 0 1 2 0 1 2. We can find its characteristic equation by the same shortcut method. Here, since it is 3 by 3 matrix, we are starting from lambda cube. The next sign is minus. Then next we need to find next in the same sum of diagonal entries. Here sum of diagonal entries 1 plus 1 plus 2, that is 2 1 plus 1 to 4. Since we started from lambda cube, next term next lambda square minus 4 lambda square. Next here we put minus, then we need to put plus. Next we need to find first we need to consider diagonal entries. First diagonal entry is 1. Then remove this column and this row. Then we will get a 2 by 2 matrix. Then and we need to find determinant of this 2 by 2 matrix. Here this determinant of this 2 by 2 matrix is 1 into 2 minus 1 into 4, that is minus 2. Next we need to consider the very next diagonal entry, that is 1, and same method we can use here, that is we remove this column and this row. Then we will get a 2 by 2 matrix, that is 1 3 0 2. We need to find its determinant. Its determinant is 2. Same argument for the last diagonal entry, that is 2. We need to remove this column and this row. This column and this row. Then we will get a 2 by 2 matrix, that is 1, 2, 0, 1. We need to find determinant of this 2 by 2 matrix, that is 1 by 1, that is 1. Okay, we found the coefficient of lambda square. Then this will be the coefficient of lambda. Here minus plus, then we need to insert the sign negative. Then next thing is, next number is, that is constant, is determinant of this matrix. What was the matrix? 1, 2, 3, 0, 1, 4, 0, 1, 2. You need to find determinant of this matrix. We can find this determinant of this matrix is 1 into 2 minus 4, 2 minus 4, which is equal to, I am using column. I am using first column to find its determinant, since all other entries are 0. So the determinant is 2 minus 4, which is equal to minus 2. Which is equal to minus 2. Minus 2, that is plus 2, equal to 0. This will be the characteristic equation of the given matrix, this matrix. That is, we can simplify by lambda cube minus 4 lambda square plus lambda plus 2 equal to 0. This is the characteristic equation of this matrix.